Today we are going to learn about reactions of benzene. Even though benzene is unsaturated, it doesn't give addition reactions. The most common reactions of benzene are substitution reactions, okay? Under normal conditions, of course. Okay, it's unsaturated. It's like alkene and alkyne. You expect it to give addition reactions, but it's not going to give addition reactions. It's like alkanes, okay? It's going to give substitution reactions. So the reason behind, because of the structure, it has a highly stable structure, so it retains it in chemical reactions. So we are going to learn about halogenation, nitration, alkylation. Halogenation is like kind of we are going to add halogens to the structure. Nitration, nitro groups, alkylation, alkyl groups to the structure. Let's do one by one. Halogenation part: in the presence of a Lewis acid catalyst, benzene reacts with bromine and chlorine. Lewis acids are this iron 3 chloride and aluminum chloride. Okay, so now let's write the reactions. Okay, so what happens? You have the benzene ring. Okay, this is benzene ring, 6 carbon, 6 hydrogen, and you are going to add halogens. Okay, fluorine, chlorine, bromine, but chlorine and bromine part is common. Okay, we are going to add Cl2. Okay, so what happens in presence of AlCl3, aluminum chloride catalyst? So is one chlorine atom is going to replace the one of the hydrogen of the benzene ring. I'm just going to replace this one, so it's going to be Cl, and the hydrogen will go with the other chlorine atom to form hydrochloric acid, HCl. Okay, so it's going, chlorine is going to replace one hydrogen. So of course you can change this into what? Br2 is going to be bromobenzene. This is chlorobenzene. It's going to be bromobenzene. Hydrobromic acid. Same stuff. But catalyst you can use iron 3 bromide at that time. Okay, very good. The second one, nitration. For nitration part, nitro group is important, and you get nitro group from the concentrated nitric acid and sulfuric acid. Okay, so the same stuff here. You have the benzene ring, okay, and then kind of it's going to give reaction with nitric acid, concentrated nitric acid, HNO3. Okay, sulfuric acid kind of is a catalyst, that H2SO4 is used to produce nitro group. So what do we have? We have nitro. We have nitro benzene, NO2. And what will happen to the hydrogen there if it's going to, so it's going to form water, okay, H2O. Okay, so that's it. Nitration of the benzene ring. Concentrated sulfuric acid, concentrated nitric acid combination, this mixture and benzene. You mix them and you get this. You should be able to write the reaction here. And then the last one is going to be alkylation. For alkylation part, so it's kind of free, it has another name, Friedrich-Krauss reaction. So this, you have the general formula actually here. C6H6RX, C6H5R. R is the alkyl group there. Okay, so let's rewrite it actually. So what do we have? We have the benzene ring, and you have alkyl halides. Okay, let's say CH3Cl. Okay, Lewis acid you use AlCl3. Okay, now what happens is going to so it's going to split kind of. Okay, this part is going to replace hydrogen there. Okay, so what will happen? And hydrogen will go with the chlorine. Let's write. Okay, so it's going to be, it's going to be methylbenzene, CH3. Okay, so you get what? You get HCl. So the point, of course, you can change the alkyl group. So you get ethyl chloride, okay, such thing. So ethyl benzene, you will get ethyl benzene. This is toluene. This is important. It's used as a solvent. Okay, so this is why you have the reaction here. And then, okay, that's it. That's it for me. Do we have any other reactions? Yeah, of course, because it's a higher carbon, you can burn it. If you burn, you get carbon dioxide and water. And it's not a good fuel because it requires lots of energy. But they add to gasoline, okay, because it is It's kind of anti-knocking agent, okay. You can run engines better if you use benzene, okay. Benzene is a higher carbon molecule. Gasoline is a mixture of higher carbons, of course, okay. But inside gasoline you have benzene, okay. It's 1% something, because it is not good, okay. It causes cancer, so this is why benzene causes cancer, so this is why it's not good to use. So they are decreasing the proportion of benzene in the gasoline, okay. So that's it. It's a good tool to use to make other goods. Tools, of course. It's kind of a part in a piece of gold in the treasure of treasure of organic compounds. Okay, it's good for us. We can use it to make other. For example, you can make polymers. Okay, epoxy resins from benzene, and then you can prepare some glue. Okay, so you can make some medicine, like, for example, in the structure of let's say some biochemical compounds, phenylalanine, you have benzene ring. Okay, yeah, that's it I have for you today.